Welcome back. Welcome to our favorite function once again, the say my name function that runs find my name, that runs print name, and then finally prints the name. Now, there's another piece to the puzzle. There is another part of the execution context that we have not discussed. And I know, it seems like a lot, but trust me, once you get this stuff, and I know I'm repeating a lot of things, but by repetition, we should have this ingrained in our brains for the rest of our career. So bear with me. I know I say execution context 1,000 times in a video, but hopefully it'll stick to you, even though you might get a little bit annoyed with me. Now, this other piece of the puzzle when it comes to the execution context that we haven't discussed yet is that each world, that is, each context, has a link to its outside world or a link to its parent. And this outer environment depends on where the function sits lexically. We know that word, right? Lexically means where the function is written. So let's figure out what that means. In here, if I created a new variable, let's call it variable x that equals x. All of these functions, find name, print name, say my name, is going to be able to access this variable, this global variable. If I run console.log x here in find name, even though find name gets added to the stack at the very end, if I run this, I don't get any errors. I have access to x. All of these functions have access to the global scope. Let's see how this works in a diagram. All of these functions have a global lexical environment. That is, they're written in the global space to not inside of another function, just on the main page, they just get attached to the window object or the global object. So all these functions have their own variable environment. They have access to each their own variables, but they also have this little link, what we call a scope chain. And this scope chain links and gives us access to variables that are in our parent environment. In this case, the global environment. So when we assigned variable x to x, when I ran print name console log x, it first looks in the variable environment and only sees the variable c here. And says, I can't really find this here. Let me go up the scope chain, or in this case, down the scope chain, and see if it's attached to my global lexical environment. And it finds the x variable all the way down here off the screen and is able to console log x. Again, if we go back to our code, console log x works because, well, we can go down the scope chain. The JavaScript engine is going to say, all right, I have variable b, but don't have variable x. Let me go into my parent environment. Oh, and I see x here. I can log it. And by the way, in the diagram, the console log was here in the print name, but it's the same thing. It's going to work both ways. Now, what I just demonstrated to you is called scope, or static scope to be exact. Remember this phrase that we saw before? In JavaScript, our lexical scope, that is available data, variables, where the function was defined, determines our available variables. That means variables in our local environment or variable environment. And it doesn't really matter where the function is called. No matter where the function is on the execution stack, what matters is where the function is written. And there's an interesting characteristic of that, right? This idea of lexical scope, which is also called static scope in a language, means that only by looking at the source code, we can determine which environment the variables and data are available in. And that's what the compiler does. The JavaScript compiler looks at the code and attaches all these scope chains before it even runs the code. How cool is that? Because we have lexical scope. We know what environments are linked to each other, and we know what data can be accessed by which function. And the scope chain starts where the variable is defined and goes all the way down to the global context to see if the variable exists. So that's what scope means. Scope is, hey, where can I access that variable? Where is that variable in my code? Let's take this example a little bit further. Let's say I have a new function. Well, it still does the same thing, but it's written lexically in a different way. If I run say my name here, and I invoke this function and I click run, I get function find name. That is because when I run this function, well, it returns this part of the code, which is function find my name. So using that logic, let's invoke this function once again by adding another curly bracket. Remember, this gets turned into the find name function. And this find name function, I'm going to invoke it with a curly bracket. Oh, and let's remove this console log because we don't need it right now. If I click run, I get function print name. All right, so I'm here now. It's returned this part. Let's run this function again. I'm going to add another curly bracket. And again, we're just using whatever the JavaScript engine does to run our function. If I click run, hooray, we got the same result as last time. But as you can see here, these are all lexically scoped, different than before, right? Previously, all these functions had global lexical environments. What do they have now? If you were the JavaScript engine and you are looking at this code, you haven't even run this code, how would you link the chains together? Well, it will look something like this. Instead of having the links like this, you'd have them like this. What we call a function lexical environment. That is, find name is written inside of say my name function. So find name's function lexical environment is say my name. And print name's function lexical environment is find name. So the scope chain goes down like this. So that hypothetically, print name has access to B and A. Find name has access to B and A. Let's test this out. If I go to print name, I can console.log C, and if I run this, awesome, I get C. That's great. What if I console log B? According to the diagram, I have that scope chain where I can access the parent environment. So if I run this, hey, look at that, it works. What about A? If I run this, beautiful. So by running console.log A, I'm going up the scope chain, saying, hey, is A here? Nope, don't have it, keep looking. And then going up the scope chain to say my name, says, hey, do you have A here? Yep, I have it, here you go. What if I remove this and instead use it here? Can I look for A? If I run this, yep, I can look for A. But what about C? Nope, I get a reference error. C is not defined. Why is that? Well, if we go to the diagram, C is up over here. And when I do console log in find name, it's going to look in the variable environment, says, nope, no C here, keep looking. And then it's going to go into the say my name's variable environment. It says, hey, is C here? Nope, keep looking. And then it goes into the global environment. It says, hey, is C there? Nope. So it gives us a reference error. I have no idea what you're talking about. You're doing something strange here. I'm going to throw an error. This principle in JavaScript is going to be used throughout the course, and it's very, very important. So if you need to watch this video again, go ahead and do it. But I hope you get this point. In this video, we learned that the global scope is the outermost scope. So variables declared outside a function are in what we call global scope. And they can be accessed in any other scope. That is, inside of the functions, we can always access global scope. Now, local scope, that is, any scope that is local to a function. Now, variables declared in this local scope are accessible within this scope, as well as any scopes surrounding it. And that's all scope is. It just defines the accessibility of variables and functions in the code. It tells us what we can access, what we cannot. And just as a little refresher, remember, undefined is an actual type in JavaScript. Undefined, when we get something undefined, it means, yes, we have this variable, but it's not assigned anything right now. Versus something like a reference error says, hey, this is completely undeclared. Scope chain can't find anything. By the way, back to this slide. Remember how I told you that eval and the with statement are not a good idea? It doesn't help our JavaScript engine optimize our code? Well, it's because of the issues that it has with scope. Because with eval and with, you can actually change how scope and scope chains work internally in JavaScript. And that makes things difficult for us. Because we have lexical scope, the compiler can just look at our code and create the scope chain and understand what's going to happen. But if we start changing those around with something like eval, it's going to trick the JavaScript engine, and it might have to de-optimize some of our code. All right, let's take a break, and I'll see you in the next video.